Look up at the night sky. We see stars, planets, the vastness of space, but what we don't see is just as important. Our planet is surrounded by a growing cloud of space, junk, old satellites, rocket parts, even tiny fragments from collisions. This debris, invisible to the naked eye, poses a serious threat to the future of space exploration and even our way of life here on Earth. Imagine a highway with thousands of cars, trucks and motorcycles all traveling at high speed. Now, imagine if those vehicles were never removed and new ones were constantly added. That's essentially the situation in Earth's orbit. Every piece of debris, from a spent rocket booster the size of a bus to a fleck of paint, travels at thousands of miles per hour. At these speeds, even a small piece of debris can cause significant damage. Collisions can create thousands of new pieces of debris, each a potential projectile in a dangerous chain reaction. This is the alarming reality of space junk, a problem we created and a problem we must solve. It began in 1957 with a beep heard around the world, Sputnik, the first artificial satellite launched by the Soviet Union. This event marked the dawn of the space age, a time of incredible discovery and technological advancement. Since Sputnik, thousands of satellites have been launched into orbit, transforming communication, navigation, and our understanding of our planet. But this progress has come at a cost. Every launch, every mission has left its mark on space around Earth. Early satellites designed for short lifespans eventually burned up in the atmosphere. But many others remained, joined by discarded rocket parts, mission-related debris, and fragments from occasional collisions. As more and more objects entered orbit, the risk of collisions increased. In 1978, NASA scientist Donald Kessler proposed a disturbing scenario, a cascade of collisions in Earth orbit, creating an impenetrable belt of debris that could make space exploration impossible for generations. This became known as the Kessler Syndrome. The Kessler Syndrome is a chilling example of a runaway chain reaction. Imagine one collision creating thousands of new pieces of debris. These fragments then go on to hit other objects, creating even more debris in an exponential cascade. As the density of debris increases, so does the probability of further collisions. This chain reaction wouldn't happen overnight. It would unfold over years or even decades. But the consequences would be devastating. Satellites essential for communication, navigation, and Earth observation would be at constant risk. Manned space missions would become incredibly dangerous, if not impossible. The effects of Kessler Syndrome wouldn't be limited to space. Our reliance on space-based technologies is deeply woven into modern life. Communication systems, GPS navigation, weather forecasting, financial transactions, and even disaster relief efforts all depend on satellites. Disruption to these systems would have profound and far-reaching consequences for our global society. Section 4. Is Kessler Syndrome inevitable? The good news is that Kessler Syndrome is not inevitable. We have the ability to find solutions, but we're running out of time. The amount of debris in Earth's orbit is increasing every year. Currently, there are over 23,000 pieces of debris larger than a softball being tracked, but these are just the objects we can see. The European Space Agency estimates over 128 million objects smaller than 1 centimeter. These smaller objects still pose a significant threat, capable of causing serious damage to spacecraft and satellites. While a full-blown Kessler Syndrome scenario isn't happening right now, there have been several close calls, and a few notable collisions that highlight the urgency of the situation. The 2009 collision between Cosmos 2251 and Iridium 33 created over 2,000 pieces of trackable debris. Section 5. A new space race, a growing threat. In recent years, the situation has become more complex with the rise of mega-constellations, massive networks of satellites launched by private companies to provide global internet coverage. While this technology holds great promise, it also significantly increases the number of objects in Earth's orbit, intensifying the risk of collisions and potentially accelerating the timeline for a Kessler event. For example, SpaceX's Starlink constellation alone plans to launch thousands of satellites in the coming years. While SpaceX and other companies are implementing mitigation strategies, such as deorbiting satellites at the end of their lifespan, the sheer scale of these constellations presents a new set of challenges for space sustainability. Section 6. Cleaning up our act solutions and challenges. Addressing the space debris problem requires a multifaceted approach involving international cooperation, technological innovation, and a shift in how we think about our responsibility for space. The good news is that efforts are already underway to develop and implement solutions. One approach is to prevent the creation of new debris. This involves designing satellites with end-of-life disposal plans, such as deorbiting them into the atmosphere or moving them to graveyard orbits. It also means encouraging sustainable practices in the space industry, promoting international guidelines for responsible space operations. Another approach is to actively remove existing debris from orbit. This is a complex and challenging task, but various concepts are being explored, from robotic arms to space-based lasers to giant nets designed to capture and deorbit large pieces of debris. However, developing these technologies is only part of the solution. International cooperation is crucial. Space debris is not a problem for any one nation to solve. It's a global challenge that requires a coordinated global response. Section 7. For future stargazers, protecting our spacefaring legacy. The night sky has inspired wonder and exploration for as long as humans have looked up. It represents the boundless potential of discovery and the interconnectedness of everything in the cosmos. But our current trajectory of space debris threatens to turn this symbol of hope into a cautionary tale. We have a responsibility to address the space debris problem, not just for ourselves, but for future generations. We must ensure that the space environment remains accessible and safe for continued exploration, scientific discovery, and the advancement of human knowledge. The challenge is significant, but it is not insurmountable. By acting now, by working together, and by embracing innovative solutions, we can protect our spacefaring legacy and ensure that the night sky continues to inspire wonder and exploration for generations to come.